Hello, I am Odit, the Assistant Professor of Gargi Memorial Institute of Technology. In our last lecture, we have know about the what is polarization and which type of light wave we are used in the polarization. Actually, light wave is a transverse wave. We are already know by the in a last lecture, and what is the plane of perpendicular and what is the plane of vibrating, what is plane of vibration along the paper and perpendicular to the paper. Okay, in today's lecture we have to know we have to try to have to understand the how the we try to understand the how the polarization is done by reflection. Polarization is done by reflection. Is it clear? And also we try to develop a Brewster's law. Okay, so suppose this is a we get a transparent transparent material. Okay, so now if you immerse some light wave along this direction, so this is the plane of perpendicular to the axis, so this is the ordinary wave. There is I am drawing here a two vibrational plane, one along the parallel to the paper and another along to the perpendicular to the paper. It is perpendicular to the paper and this one is parallel to the paper. If this light is incident on this plane, due to the reflection, we get some reflection and refraction also. Okay, so this one is called unpolarized light. This one is called partially polarized light. This one is also partially polarized. Now we have to know about the Brewster law. Okay, now what is Brewster law? Brewster says that mu, the refractive index of this transparent material is always equal to tan IP. IP is denoted by polarization angle. Now what is this? What is polarization angle? Okay, now I am incident a wave with a specific incident angle. Every material have a specific polarization angle. Suppose I am getting a glass material. Okay, suppose this is a glass. When I am incident a light wave with an IP polarization angle of this material, then after the reflection, only perpendicular of the the wave which vibrating along the perpendicular to the axis, which is reflected, and rest of the parallel to the axis and the rest of the perpendicular to the axis is reflected through this plane. How it is possible? Okay, now so this one is vibrating it is not perpendicular. This type of wave is not perpendicular or parallel through this surface of the medium, but this one is actually parallel. This, remember that this one is vibrating through this direction and this one is the plane of reflection. So this is the parallel to the plane of reflection. So this wave, this wave actually, this which wave, the pointed wave, is vibrating perpendicular to the paper. It is actually parallel to the surface of the medium. So this one easily reflected. This one, that means suppose this is the upper space of the material. So some vibration is going through this type of vibration, and after reflection it is coming over through this direction. It is clear, this is coming like that. Okay, but in the case of the perpendicular of the paper, it is vibrating along this axis. So this is not possible. The whole wave of the which is parallel to the paper is going through the refraction. It is not reflected by this surface. Only which vibration is parallel to the surface, those vibration of the light is reflected by this surface through this direction. Okay, and it is also happen when you this incident wave with a polarization angle of that material. This is the actually polarization. So this is the unpolarized light. This is the polarized light. This is the partially polarized light. And by through this Brewster law, so now from the Brewster law we can also prove that the angle between from this Brewster law. Now it is clear for everyone what is unpolarized light, what is how the polarized light is generated. It is due to the vibration of this wave is parallel to the surface of the reflection. That's why this wave only be reflected by through this surface. Rest of the wave is only be refracted through this material. Okay, that's why we get a fully polarized light, because this wave have only one plane of vibration, because the partially polarized have both plane of vibration, because we get a two type of plane in the two type of plane of vibration by through our drawing actually. Okay, by through our drawing. So we only get the one plane of vibration. So such type of wave is light wave is known as polarized light. Okay, clear? So this one is called polarized light. And another thing I am try to express you by through the Brewster law we can prove that the angle between reflected light, reflected and transmitted ray is always 90 degree when incident light is in IP or polarization angle. Is it clear for everyone? So we can prove that this angle between the reflected ray and the incident ray, the angle between this is 90 degree by through the Brewster law. Okay, is it clear for everyone? it is actually coming from the Brewster law. Okay, so let's prove it. Okay, so we have a equation mu is equal to tan IP. This is the Brewster law. The refractive index is equal to the tangent of the polarization angle. We can rewrite this one sin IP by cos IP. In our written notes, it may be written as a only single p, but in our lecture I am written as a IP. Okay. Another thing, I think here I am writing in my notes, PDF notes, mu is equal to sin p by sin I, but this is not a sin I actually. This is actually sin R from the Snell's law. This is the equation 1, and from the please clarify the mistake in my PDF note. From the Snell's law, I am right here that I'm right here that sin sin IP by sin R. Actually, I am right here the sin P by sin I actually, but it is obviously sin P by sin R. Okay, what is R? Suppose R is the transmitted angle. So from the Snell's law, IP by I R. Clear? This is the second law of refraction. So this is the second equation. Now compare this equation. Sin IP by cos IP by sin IP by sin R. Okay, IP. So sin R is equal to cos IP. So if this angle is IP, this one is also IP. Okay. So we can rewrite sin R is equal to sin 90 degree minus R is equal to 90 degree minus IP. We converted the cos into sin. So this is become sin is equal to 90 degree minus IP, or R plus IP is equal to 90 degree. Is it clear? So the angle between R plus IB is equal to 90 degree. That means if you geometrically think about this angle, this is also become 90 degree, and this is explain the whole one. Okay, so this is the proof of the Brewster law. Another thing is that for the glass, the polarization angle is 57.5 degree. When you incident some ordinary light with an 57.5 degree, after this reflection, after the deflection you get a only polarized light. But it is a polarized or unpolarized? How we can know that? How we can know that it is a polarized or unpolarized light? So for the analyze of this, it is polarized or unpolarized, we have two methods. Okay, so let's explain what is that method. The first method is tourmaline crystal. Here is a one type of crystal we have. This crystal is known as tourmaline crystal, and this one is called optical axis. Okay. If the plane of vibration is put it along through this crystal the same direction, then the intensity of this light is maximum. But when the plane of the incident wave is perpendicular to this crystal, if it is vibrating along this direction, so the intensity of this light after the refraction through this material is become zero. We cannot get any type of light, but it is parallel to the axis. We get the maximum energy through this crystal. Okay, so we get a transparent slab, then we incident some unpolarized light. This is the IP. After the reflection, we get a one plane of vibration. This is the partially. But when you put a tourmaline crystal along the front of this polarized light, okay, when we rotate this, if the axis when you put the tourmaline crystal along this direction, because the vibration along this the perpendicular of the paper, and if you put the axis of the tourmaline crystal is also perpendicular to the paper, then we get a maximum light. But when we put this crystal is perpendicular to the plane of vibration, then we cannot get any type of light. So through this method we can easily prove that this after the reflection this light is become polarized or unpolarized. Okay, so there is one process. So another process is Biot's periscope. Okay, in this method we need a two slab of light in a box. This is P1, this one is P2. Okay, when we are incident some light in a first slab, this is a unpolarized light. After the reflection, it is produce a polarized light. Okay, again after the reflection we get also a polarized light. Is it clear for everyone? Okay, polarized light. When the P1 is perpendicular P1 is parallel to the P2, then if the angle of incident is IP, then we get we can see the intensity of the light or after second reflection. If you change the angle between these two plates, then we cannot see any type of light. That means no light is reflected through the second reflection. So that means this light is polarized. Clear? So this light is polarized. Okay, so today's lecture we have to know about how the polarization or reflection is happen, and what is Brewster law, and what is polarization angle, and from the Brewster law we can easily prove that the angle of transmission and angle of refraction. So angle of transmission and angle of reflection is always 90 degree. Okay. If the angle of reflection and angle of transmission is 90 degrees, then the total one is 180 degrees. So this point to this point is also 90 degree. Clear? So we already proved that. And this is the angle of polarization light. Then we know about the terminal crystal. Now one thing we have to know, that what is that tourmaline crystal? What is that tourmaline crystal? Okay. The example of the tourmaline crystal is calcite crystal. Okay, this is the colorless transparent crystal. The chemically it is hydrated calcium carbonate. Okay. So one of the example of the tourmaline crystal is maybe CaCO3. Okay. So this is the end. In our next lecture, we try to develop how the polarization is done by the refraction. In this lecture we know about how the polarization is done by the reflection, and in the next lecture we have to know about how the polarization is done by the refraction. Because now what is in two lecture, now what is polarization? Polarization, the ordinary light have a millions of plane of vibration, but after any process we just need one plane of vibration, and this one plane of vibration of light wave is known as polarized light. Clear? Okay, thank you.